So you should also be able to find one-sided limits when your function is given as a piecewise function without graphing first. So this is really important. You don't want to waste time graphing the function first. So if I want to find the limit as x goes to 3 of f of x, okay, I'm going to have to find first the right and the left-handed limits so that I can then find the limit as x goes to 3. So the limit as x goes to 3 from the left of the function f of x. Now from the left, I need to think about which function am I looking at. As I'm coming in from the left, I'm looking at the values less than 3. So I'm going to look at that function x squared minus 5. So that one right there. So the limit as x goes to 3 from the left of f of x is equal to the limit as x goes to 3 from the left of x squared minus 5. I can now do direct substitution. I plug in and get 4. So notice I no longer have that limit notation once I do direct substitution. So now I'm going to take the limit as x goes to 3 from the right. So same type of thing. From the right is going to be values that are greater than 3 that are coming in from the right. So the limit as x goes to 3 from the right of x plus 2. I'm going to plug in the 3, so 3 plus 2 is 5. Now because those two one-sided limits are not the same, that means that our limit then as x goes to 3 does not exist. Now notice how I'm putting in that notation. I don't have it at the 3 plus 2 anymore. This is very, very important. I will be very particular about notation, so you want to make sure about that. So our limit does not exist. Okay, so really make sure that you're keeping track of notation as you're going through. So since the limit from the left is not equal to the limit from the right as x goes to 3 of f of x, my limit as x goes to 3 does not exist. Okay, so looking at this one, and you may want to pause and try on your own first. So for this one, the limit as x goes to 2 from the right, 2 from the right is going to be the values that are greater than 2, so 8 minus x is going to be the piece I'm going to look for. I'm going to plug in 2, which I get 6. Okay, 2 from the left. So I'm going to take the limit as x goes to 2 from the left, which is going to be less than 2, so that's the x squared. And I'm going to plug in, so that gives me 2 squared, which is 4. So it doesn't ask me this, but that does mean that the limit as x goes to 2 does not exist. Okay, so the limit as x goes to 0 from the right would be values of x that are greater than 0, which again is that x squared. I plug 0 into x squared and I get 0. Now, it's asking me for the limit as x goes to 0 of h of x, but to find that, even though it's not asking for it, I do need to find the limit from the left because I need to see if the two one-sided limits are the same. So I take the limit as x goes to 0 of h of x from the left, which is going to be x. Oopsie, wrong notation there. So limit as x goes to 0 from the left of x. Okay, and now I plug in, and that is 0. So because those two one-sided limits are 0, my limit as x goes to 0 is 0. Okay, but I needed to find that left-handed limit on my own first. Okay, so last one. So here I have another piecewise function. I'm going to take the limit as x goes to 1 from the left, which is the natural log of 1, which is 0. 2 from the left, be looking at the x plus 6, which is 8. 1 from the right would be again looking at that x plus 6, which is 7. My limit of 1, again, I haven't found my limit of 1 from the left, but I see, oh, I did find my limit from the left, and those two are not the same, so it does not exist. And then 2 from the right, it's going to be the values greater than 2, so I'm looking at x cubed, which is 2 cubed, which is 8. So notice I am making sure that I somehow note which function I'm using.